All right, guys, let's begin it. Good morning, everyone. My name is Shashank KM. I am representing IE Mechatronics Manipal. I'm here to explain to you how sensors work, what are the applications, what are their purpose, what they are used for, how they can be used, and how you can use them. So I want to go through this webinar in an application-based, practical-based learning so that you are able to understand how they are used, why they're used, etc. So let's begin. My name is Shashank KM. I'm 19 years old. I'm doing my bachelor's in mechatronics in Manipal. I'm a member of IE Mechatronics. I'm a team member of electronic subsystem in Marshover Manipal. I'm currently researching on antennas. I have made a few drones before. I've made one tricopter. I've made two quadcopters. I'm experienced in making small hobby electronic projects using Arduinos, sensors, actuators, microcontrollers, etc. If you have any questions regarding the above, please feel free to contact me personally. So why should we study about electronics? Like, what is the purpose? Why should we be interested in something that's everywhere? So that's literally the answer. It is because it is everywhere. Electronics is such a huge part of our modern world. It is everywhere. You can see it anywhere. It will be on your phones, it will be in your laptops, it will be in your cars, it will be in your jobs. You can use sensors everywhere. You can use sensors, and these sensors are so important to us nowadays that we cannot live life as we know it without all these electronic circuits. So there's a lot of interesting topics in electronics. There's a lot of interesting concepts. There's also a lot of new upcoming innovative ideas that you are able to see. So that's also a very important reason why you should study about electronics. It is extremely interesting. There's so many things that you get to know, that you get to learn, that you never thought before could be possible, that is being done using electronics nowadays. It is very easy to get into. There's a lot of resources online. There's so many project materials that you can find online. There's so many people who are willing to help you. And yeah, the community is huge. There's so many people who are willing to help you. You just need to ask. There's so many forums. There's so many places where you can ask, how does this work? Why is this happening? So people are ready to answer you. People will be very, very enthusiastic actually to explain to you why this is being done this way or that is being done that way. So the community is huge. It will be very helpful. And you can also do many small projects on your own. You can use the sensors which I will be telling in this project, or you can research about your own sensors, or you can, think about your own projects. You can make some small projects on in your life, in your home, which will be helpful to you. You can make a lot of things with the sensors which I'll be telling you. So you can think about small projects of your own which you can implement in your life. And seeing a finished project is so satisfying. Like once you finish a project, you put blood, you put sweat, you put tears into it, and when you see it, right, it gives you it gives you that feeling of such happiness. Like you'll be so happy, like it is working. You'll be so satisfied, you'll have a good night's sleep and everything. And it is great. The feeling is great when the project is done, when it's finished, it's working, it's beautiful. The feeling is absolutely marvelous. All right, let's proceed. So what exactly are sensors? Sensors are a term which are being used like quite a lot nowadays, especially in the last 10 to 15 years. People are using sensors a lot. People are saying like sensors are used everywhere and stuff. So, but what exactly are sensors? Sensors are basically devices which will help you communicate with the physical world. Like if you have a pressure sensor, the sensor will tell you if something is being touched, if there's the pressure being applied on the sensor or not. So it will help you interact with the physical world around you. A light sensor, for example, will see if there's light coming, is the light falling on it or not. So they will detect the light, it will sense the light. Now, there's a bunch of different types of sensors. There's ultrasonic sensors, there's accelerometers, there's gyroscopes, etc. So basically what sensors do is They are based on some techniques and their processes which are beyond the scope of this seminar. But I will tell you, there are a bunch of technologies and there's a bunch of topics that we've actually covered in physics, like Peltier effect, like Hall effect, etc. All these sensors are based on those effects, and using those effects, they are able to sense the physical difference, like a change in the physical world. So basically what a sensor does is it measures something in the physical world. It notices a change in the physical world, and it will represent that change in a way that can be measured. Understand? So there'll be a change in the physical world, and the sensor will represent it in a way that we are able to understand it. We are able to see it and understand this change that has happened. So that is what a sensor does. Now, another common term when you're discussing about sensors is transducer. So what exactly is a transducer? A transducer is a device which converts one form of energy into another form of energy. So it is used to convert maybe from electrical into mechanical, mechanical into electrical, or mechanical into light, light into mechanical, etc., etc. That is a device which is used to convert one form of energy into another. So basically, sensors are a subset of transducers. Transducers is a superset, and sensors fall under transducers. Sensors, I have a here. The sensors fall under transducers. Transducers are devices which are used to, convert energy from one form into another. Now we'll be using sensors throughout the webinar. We won't be using transducer because it is the industry standard. Now, what is meant by industry standard? Industry standard is basically the term that is used to define, like, everybody in the industry, in that industry will be using that term. So it is a standard. It is a standard that everybody in that specific in the specific industry will be using only those terms. That is called an industry standard. So these are the common terms which we use in electronics or sensors. So the transducers, as I said, convert from energy from one form into another form. That is very important. What we are living right now, what we're doing right now, that is because of transducers. That is because we are able to change energy into one form or other. Sensors, as I said, they're able to sense a physical change happening in the physical world. An actuator is the opposite of a sensor. So it will take an electrical signal and it will do something in the physical world. For example, a motor. I have a motor here. Look, a motor. It is an actuator. An actuator will take electrical signals and do something in the physical world. It is the opposite of a sensor. Now, there are these other terms like microcontroller, microprocessor, and Arduino. I will go through these later. But yeah, these are the basic common terms which we use, which are used in electronics. Now, this is a slide which explains the differences between transducer, sensor, and actuator. The transducer here is a microphone. Microphone is the best example for a transducer. The audio waves which are being generated by your throat or any other audio device, that is being uh, that is being taken in, that is being sensed and used by the microphone in your headphones or earphones or something. So this is a very good example of a transducer, a microphone. Next, we have an ultrasonic sensor. This is an ultrasonic sensor which basically generates ultrasonic waves. So waves which are greater than the speed of greater than 20,000 kilohertz, and those are used to detect objects. These waves, they travel and they bounce back from objects. So an ultrasonic sensor is used to it has many applications, but one of the common applications is used as an object detection. It is used in object detection, if there's an object coming in front of it or not, on in front of the sensor or not. So next we have actuators. As I showed, motor is the best example of an actuator. This is also an actuator. This is a different type of an actuator. It's a BLDC motor. This will also move by converting electrical signals. All right, so I hope the difference are clear. Transducer, sensor, and actuator. All right, on. Now we have some basic examples of sensors. The first one is a touch sensor. You can see the small area in the center, right, where I'm pointing with the pointer. That is basically the touch sensitive area. Whenever I place a finger or tap it or something, the signal will go from the sensor to the control unit, whatever it is, that there's some sensation being tapped on the sensor. So that is what a touch sensor will output. It can either be a hold or tap or something like that, and that output will go to the control unit. The control unit is something I'll explain later. Just know that whatever the sensor senses has to go to a control unit. All right. So next we have a flow sensor. So basically in a flow sensor, it is connected between two pipes and it measures the rate of flow of a liquid. It can be water, it can be something else. And it basically measures the rate at which the liquid is flowing through the pipe. Next, we have a flex sensor. A flex sensor is basically used to check if there's bends or not in the sensor. So every time there is a bend, the sensor will output to the control unit that there's a bend in that specific area. So flex sensors have a lot of applications, as do all of these in general, but you can use a flex sensor to create an artificial hand of your own. Next, we have an infrared sensor. An infrared sensor is basically used for communication purposes. Infrared waves are used uh, to communicate between your remote control and your TV, your remote control and your AC or your projector, etc. There is going to be an IR receiver. This is an IR receiver module. And then there is going to be an IR transmitter. The data is transmitted using the transmitter and the sensor will receive it, and you can use the sensor to do some to use that data and do something else. You can get that data and do something else with it. Next, we have a microphone. As I said, audio waves converted into electrical signals. We also have GPS sensors. GPS sensors are everywhere, including the phones and including your cars. They basically give you a location of that module of that GPS sensor in the whole wide world. They have great accuracy nowadays, even up to like 10 centimeters as well. So it's really, really cool. We have temperature sensors. Temperature sensor basically, as the name suggests, it measures the temperature of a particular thing. It could be anything like a table. It can be some component. It could be your battery. It could be anything basically. It will measure the temperature and it will tell you. LiDAR is sort of similar to radar, sorry. It instead of using radio waves, it will use light waves. And using the light waves, it will check if there's objects nearby. It is used for obstacle avoidance and obstacle detection. It is basically for detecting obstacles. Now, a lot of these sensors have different processes behind it. They have different technologies behind it. And it is up to you as a designer to choose one sensor which is the best for you. Like it depends on the application, not on the sensor. You don't first pick a sensor and then be like, yes, I'm going to do this with it. You need to have a project, you need to have an idea in mind, and then you need to pick a sensor for that. That is how you must learn this electronics. You can also, like, if you have some sensors lying around, you can do random projects with it, but I would suggest think of a project and then look for sensors for it. It would be much more thrilling and it would be more challenging for you as well. Now these are some other examples of sensors. There's something called an accelerometer. This is an accelerometer. Basically what it does is it measures the linear acceleration. Like if the sensor is moving in this direction or above or like below, or if it's moving like in a straight line, then this accelerometer will tell me that it is moving in this direction or that direction. All right, so an accelerometer will tell me the linear acceleration, like what is the speed of the, like we can calculate speed using that linear acceleration. Next, we have something called a gyroscope. I don't have a gyroscope with me at the moment. So a gyroscope will basically tell you the rotational velocity of an object. So it will basically tell you if it's stable, if it's moving, if it's inclined or something like that. If a gyroscope will tell you like what is the orientation of the of the of the of the module. Next, we have a barometer. A barometer will measure the pressure, like the atmospheric pressure. It is also a sensor like this. It will basically measure the atmospheric pressure on the module. So using the barometer, you can actually check how high, at what altitude your sensor is. So it is used to measure heights. It is used in aeroplanes, etc. It is used in drones as well. So it will tell you at what height the the drone or the thing the sensor is, the system is in. Next, we have a rate sensor. It basically measures at what rate a process is happening. For example, if you have a wheel and it's moving, you can have an encoder, which is basically a rate sensor, which will tell you how fast the speed the wheel is spinning. So it will tell you how fast something is happening, a process is happening. So these are some other types of sensors, examples of sensors. So what I feel is that the best way to understand sensor is to look at it from a practical point of view. So let's imagine that we are making a drone. So what does a drone do? It flies, it hovers, right? It will lift off the ground, it will hover, it will fly, it will move around, it will move like this as well. So what would be the basic amount of sensors which you'll be using? Like what could be the sensors? I've already told you all the amount of like the sensors which you will need. So what would be the sensors you think? If you want, you can type it in the chat. What sort of sensors would you apply to this project and why? So think of a lot of factors, okay, like at which height it will go and all these other things that you will have to consider when you're picking sensors and when you're choosing sensors. So for this specific project, I have the solution. These are the basic components. These are the basic sensors you will need. So as I said, an accelerometer, it measures the linear acceleration. It will tell you how fast the drone is going in a straight way, how fast it is going. So what is meant by 3DOF as is in the bracket? The 3DOF means there are 3 degrees of freedom. So it means there is 3 directions in which the accelerometer can measure the acceleration. So 3DOF means one is X, one is Y, and one is Z. So if the accelerometer were only one DOF, it would only be in one direction. It won't measure it in the other 2 directions. It will only be in one direction. So 3DOF means the amount of directions it can measure in. A gyroscope is also 3DOF. There's 3 rotation motions, and then this. There's 3 rotation motions that you can do with a drone, and you can check the position of the drone using the gyroscope and the accelerometer. Next, we have a magnetometer. A magnetometer is basically a sensor which will measure the magnetic field around the sensor. So it will be a sensor like this. There are always obviously magnetic fields and electric fields around you, right? So what a magnetometer does is it will measure the magnetic field in 3 directions, and it will tell you the orientation with respect to the North Pole and the South Pole. So basically it is a compass. A magnetometer is a compass. It will tell you the direction it is inclined in, the drone is inclined in. Next, we have a barometer. As I said, it will tell you the height at which the drone is flying in. We can also have temperature sensor so that we measure the heat which is being output by the batteries or something. Then we have GPS as well, which will tell us where the drone is in real time in the world. So these are just some basic sensors. You can add as many sensors as you want depending on your application, depending on what you want to do with the sensor. You can make your own choices. And yes, that is basically the amount of sensors we need. These are the basic amount of sensors we need for this drone. Okay, do you guys have any questions? Which is being used. Next, we have the onboard LED. This LED it's just an LED basically you can use in your programs. It will display some output. It's not necessary to use, it's just a feature there. It's not necessary. Next, we have a power LED. This is a green LED which when powered will be turned on. It will turn on when there is power flowing through the board, as simple as that. Then again, there are digital input output. Again, remember, these are digital input and output. All these pins here are digital input and output. These are only analog inputs. And this is power rail. This is the power rail. All right, I'm going to the next slide. This is the basically the physical, like whatever you need to do physically. This is the physical, what you see when you look at an Arduino. So this is the type B cable, which I showed earlier. This is the back side of the Arduino. This is the Arduino itself. It's in terrible condition. This is these are the various types of cables which we'll use. All right. So to interface a sensor to the Arduino, you will need to make connections between the two, right? So for that, we will be using jumper cables. These are cables these are basically called jumper cables. This is called a male to female. You see, this is the male part, this is the female part. This one will go into the female part. Wherever there's a female part, the male part will go there. And the opposite way for whenever there's a male part, the female part will go there. So these are basically used to connect the sensors to each other or to the control unit, which is the Arduino. So yeah, these are the jumper cables. There's three basic types of jumper cables. There is male to female, and female to female. This is a male to male cable. You can see both sides are males, right? This is one cable. I mean, three cables. Yeah, these are three cables. Jumper cables, male to male. Next, this is, as I showed you, male to female. And then we have female to female. All right. Let's go to the next slide. This is basically the Arduino IDE. Now, basically what an IDE is it is the software you use to program the Arduino. So this is the software that you will use. You will write your code here. You will upload it using this. You will upload the code using this IDE to the board itself. So this is the general how it looks. Whenever you open it up, this is how it looks. There's void setup, void loop. I'm not going to go into too much detail about this. It's just I'll show you that this is the type of this is the IDE that you will see. Now there's a bunch of examples that you can see here. There are a lot of examples which you can try yourself. You can buy an Arduino, you can try it out yourself using all these examples. So basically what you would need to do is whenever you click on this example, right, then there will be pre-written code, and all you would have to do is connect the sensor in the given diagram, in a given way, and then you will be able to run that program. It is simple as that. It is really simple. Next, we have some basic things to know before you get deeper. We have analog and digital signals. We have power limitations. Each device has power limitations. We have a device called a digital multimeter, a DMM. I will explain the difference between grounding and earthing. And I'm not going to go too much into detail about resistance, capacitance, and induction because like everybody has done it. It's physics. People should be aware of it. And if you're not, there's a lot of good resources on YouTube. You should check them out. You should get these basics cleared if you want to proceed further. All right. So I will be telling about the first four. So basically an analog signal can give you a signal in the range. It can have a value in any range. In this specific example, in the diagram that we have, it can be between 120 and minus 120. See, at any instance in time, there will be one output. There will be one output, and it can be any value. It can be any value between 120 and minus 120, right? It can be either 120, 120, 120, no, yeah, 119, 118, or something like that. It can be anything between the two ranges, right? It can be anything in the range. So that is what an analog signal is. Next, we have a digital signal. A digital signal is only either a 0 or a 1. So in this, look, it can be either a high or a low. It cannot be in the middle. It cannot be 4.5 or 3.25 or something. It is either 5 or 0. So yeah, that's basically it. In digitals, it's 0 or 1, low or high. In analog, it can be a continuous range of values. It can be anything in that range. All right. Do you have any questions? If you don't have any questions, I can move on then. So this is the basic example of an Arduino program. This is something that I will be demonstrating right now. What we have on the top here is a buzzer. This is a piezoelectric buzzer. It will basically buzz. It buzz. It's a speaker. So I will connect this. Till then, you should look at how I'm connecting the circuit. So basically, the potentiometer, the sensor which I'm going to be using in this is a potentiometer. It will measure the, like, based on the position of the dial. This is a dial, I can rotate it. Based on this position of the dial, there will be an output that I will get. The center one is the signal one. So this is basically a potentiometer. It will give an output. It is a dial. So what I'm going to do is, every single sensor or an actuator, right, it will have power and ground. Those are two things which will always be there. So this will be power and this will be a ground. So you need to first connect the power and the ground. So this specific sensor uses 5 volts. So what I have to do is connect the 5 volt pin on the Arduino to the VCC of the potentiometer. All of these sensors will have written either VCC or 5 volt or something. That is basically where you connect the positive signal. Like it will be the positive one. So you will connect the 5 volt to the VCC. The second one, the signal wire, will be connected to the analog one. See, now as I explained before, right, there are some analog sensors and there are some digital sensors. This is an analog sensor, a potentiometer. It will, like, based on the position of the dial, there will be some value which is being output to the Arduino. So that value is in a range from 0 to 1024. And that is because the pins on the Arduino, right, the analog inputs on the Arduino, they have a range from 0 to 1023, like 1024 bits, 2 to the power 10. It's a 10-bit ADC. So it uses 10 bits worth of information. So the only range that you can get is from 0 to 1023. So if it is at the absolute left, if the dial is completely to the left, it is at 0. And when I'm moving it to the right, that's when it's at max. It's at 1023. Don't go through the code a lot. The code is not that important. I want you to understand the physical components which are being done right now, what I'm using right now. All right. So I've connected the potentiometer first. Next, we are going to connect the buzzer. So this is a buzzer. There's a positive terminal, there's a negative terminal. The negative terminal, as I said, there must be at least 2 inputs. There'll be at least 2 pins for each and every sensor and each and every actuator. Those 2 pins will be ground and power. So I'm going to connect the shorter terminal, the ground, to the ground, and I'm going to connect the longer terminal to the to pin number 11. See, in the in the code, I'll explain. There's an error in this picture. I hope you guys have noticed. It is basically the piezoelectric buzzer is supposed to be connected to 11, not 13. So that is the error in this image. I hope you have figured it out. So this is supposed to be connected to 11 here. So this is what I'm going to be doing in the physical demonstration. I've connected it to the 11th pin. And now basically what I'm going to do is I'm going to upload this code to the Arduino. And one second, I will show that. All right, so this is basically the code. It's the same code as before. And what I'm going to do is I'm going to upload this code to the Arduino. What I have to do is connect the cable, the USB cable to the computer. Then I have to take the cable and I have to connect it to the Arduino. That's it, simple as that. The computer gives me acknowledgement that the Arduino has been detected. Now what I will do is I have this code, right? I simply have to upload it. The compile, everything will be done by the software itself. It will tell the Arduino what to do, what not to do, and in the output we have it. Look, I will show you here. So if I'm moving it on the, like, on how I'm moving the dial, the buzzer will give an output. So this is something really cool, right? So using the dial, I'm going to give some information to the Arduino, and using that information gathered by the Arduino, we can use it to give some signal to the buzzer. So depending on where the dial is, the output from the buzzer will be there. So that is a very small, simple demonstration of how you can use Arduino or something. I have one more demonstration which will show you once I proceed. All right, let's proceed. This is the basic program which we just did. This is a very simple program. Don't go into all the details. Just know what I did physically, what I used to connect the sensors to the microcontroller board. So as I said, these are digital inputs and outputs, right? So what we need to do is we need to declare the pins as either input or as output, because we can't use one pin for both. And we do that using this command, pin mode output to buzzer output. So what we're doing here is we're taking pin 11, we're naming it output to buzzer, and then we're declaring output to buzzer as output. That is very simple. It is really common, and you will understand it better as you go along with it. If you're having some difficulties understanding the code, don't worry. It is very easy. You will understand it once you proceed, once you get deeper into the concepts. So this is basically what I used. This is the potentiometer. Uh, so this is a very cool device. It will give you, I explained this as well, so I'm not going to go too in depth into it. It has 3 pins. The middle one is the output, this one is the power, and this one is the ground. Now, I've been saying a lot of power and ground, power and ground. Isn't it supposed to be negative, is what most people think. See, basically how communication works between the sensor and microcontroller is it will send some voltage to the Arduino. It will send some voltage, it will send some signal in some range. It can, if I'm sending, if it's a digital sensor, it will send either high or low to the Arduino. But how does the Arduino know at which level is it? Like it just knows it's getting an information, but for it to be credible, valuable information, it needs to have a reference for it to be measured. Like this the signal that I'm getting is 5 volts above this base signal. So that base, that reference which is made, is done using the ground. Ground is very important. It is essential. It is what is necessary. It is an essential component uh, of like having, it's not a component, it is something you must understand if you're proceeding further. So there's certain power limitations which we also should consider. Not all sensors are made for all sorts of power limitation, like power consumptions. You can't just keep supplying voltage, you can't just keep supplying current to it. They have some limits, they have certain, requirement, there's certain range in which for it to work, and it is up to you to check the power limitations and make sure you're using the correct component. Make sure you're using the correct component each and every single time for your application or your project. Next, we have a DMM. A DMM is basically a device. It is a multimeter. It is a device which we use to measure voltage, current, resistance, or output. or basically connectivity between 2 points. There's certain ones which come with the capacitance as well, but it is not necessary right now. It is basically it is a tool used to measure or to check whether all your components are working properly or not. That's basically it. It is a tool that we use, and it is very, very helpful and is very, very important. You don't need it right now at the beginner's level. Once you understand how it works and how you should use it, then you can go deeper into it. But right now, DMM is not necessary. It's not necessary for you guys. Next, we have grounding versus earthing. So, as I explained before, grounding is something essential. It is for the signal that is being traveled to be correct. So, if I need a correct signal, if I want the data to be read accurately, the grounding must be done. There are a bunch of points that are there are a bunch of pins. There are three ground pins actually, one on the digital side and two on the power rail side. So those are basically used to connect different sensors to the ground so that there's a reference. All of the sensors which you'll be using will have the same reference, and so whatever signal that you will be getting can be made sense of. If there is no ground, then the signal that you'll give, the voltage that you'll get, you can't make sense of it. So grounding is absolutely necessary. It is essential. Earthing is basically a safety feature. You must see that a lot of these geysers and everything, right? They have a very thick pin in the power plug. The top pin is called the earth. Earthing is basically used to prevent the development of charge on the body. See, a lot of the times what happens is whenever certain components get old or they use a lot of power or it just happens sometimes in general, even though the body of the body of the object might be, plastic, but still there could be some electrons and charge which develop on the body of the system. It won't uh, yeah, it won't disrupt with the working of the device itself, but it might shock you if you touch it. So for example, the geysers, they have earthing. What they do is basically they connect a wire from the body of the device to the earth, and that's why they'll basically take all the excess electrons which are present on the body to the earth, so that there's no charge on the body, so you won't get shocked when you press it, when you touch it. So that is basically what earthing is. Earthing is only done when like the component which you're using is known to be kind of problematic in that scenario. Like most of the people, like we don't really earth, like most of the things we use, we don't really need earth. But yeah, it is a safety feature, but grounding is essential. Grounding must be done. Earthing not necessary. It can be done, depends on the application, depends on what components you're using. Okay, I explained analog and digital. Do you guys have any questions? Okay, if you guys don't have any questions, we can proceed further. I explained potentiometer. Now, this is an ultrasonic sensor, as I explained before. This is basically the transmitter, this is the receiver. This one will send the waves, and the waves will bounce back from the receiver, from the object and to the receiver. The receiver will calculate the time taken and everything using the chips on the board itself, and it will give you an output. It will tell you at what distance the object is from you or from the sensor itself. Now I have a really small code for this as well, so I will be showing that. Hold on. Okay, I'll explain grounding once more. Wait, I'll explain using the PPT, okay? That way you will understand. See, basically, when you're sending signals, right? Look, the signal, right? There must be a reference like this. This is zero. Like for me to understand at what level a mountain is, I need to understand what the ground is first, right? What sea level is first, right? So that is basically a reference. The ground will be the reference for to measure the voltage level like above it. So if I'm sending a signal, right, I will check that signal and compare it to ground. If the signal that is coming is greater than ground, like it depends on analog again, and analog and digital, but if it is a digital signal, if it is greater than half of the total voltage, right? So let's assume in this specific scenario, if the input I'm getting is 3 volts, since that is above 2.5 and is definitely above the ground, so that is why it is considered as high. Even though it is not 3 volts, it will be considered as high. Grounding is basically just for reference too. Like it is for reference so that the controller is able to understand what the signal is coming, like what the signal that is coming is. Is it low, is it high or something? So it is to refer to the, like this input signal will be referred to this. That is basically what grounding does. So it's just for reference. It's for telling if there's a correct signal coming in or not. Did you understand? It's basically for telling if the correct signal is coming or not. I hope you understood. So yeah, I have a small project with the ultrasonic sensor which I wanted to show you guys. This is a really simple project which even you guys can do. Basically, what I have made is a obstacle detection uh, basically system. So what it does is it will tell me if there is an obstacle within 15 centimeters uh, of my sensor. I'm doing all the connections right now. Just give me a second. Don't look at the code, okay, for this specific. It is it is a bit more complicated, and you don't need to look at all of this. It's just you don't have to look at all of this, just look at how it works. That's it. There's much easier ways for you to code for an ultrasonic sensor than this. This is just something that I randomly got off the internet to show the working of. I've made some edits to the code obviously, but yeah, this is the basics. See, an ultrasonic sensor has 4 pins. Two will be the power and ground, and then there will be two, one for input and one for output. As I said, in the sensor there is one transmitter and one receiver, right? So the transmitter will first receive data from the Arduino to send, and then the receiver will then get the data from the sensor. So it's not really necessary to go too much into depth. Just know that there are 4 pins. Okay, so I've done making all the connections. I will show you the connections now. This is basically the connection. Ultrasonic sensor is a digital sensor, so that's why both pins will be going to the digital side. Now what I have done in this project is basically once I upload it, if there's anything that comes within 15 centimeters, wait, I can't see. So this is basically the collection. This is the connections. This is the sensor. There's 4 pins. Two will go to the power rails. Look, there's the 5 volt. This is uh, the ground, and then the two inputs and output for the sensor itself. So whenever there is something which will come like in 15, till then there's no LED blinking. If there's nothing between 15 centimeters, within 15 centimeters of the sensor, there's nothing. But when there's an object within 15 centimeters, look, it starts blinking. Pretty cool, right? So this is how an ultrasonic sensor works. It will send out information, the information will bounce back, and then it will relay that information to the processor, to the controller, sorry. Look, this is a very cool sensor. There's so many applications that you can do using ultrasonic sensor. This is my first sensor. This is what I started with, and it's one of my favorites, honestly. All right, so don't look at the code. It's too complicated. You don't have to worry about this as of now. It's just It's just a code I wanted to show you. And yeah, don't worry about it at all. It's a little bit complicated, I know, but you don't have to understand it. Just understand the basics, what I told before. All right, so it can be used in a wide variety of applications, the ultrasonic sensor. Next, we have a joystick. This is basically a joystick. A joystick is a really cool sensor as well. So basically what it does is, if I move the joystick in one direction, it will tell me that the joystick is moving in that direction. And if I move it in another direction, it will tell me that it's moving in another direction. So it has basically three inputs. One is in this direction, y-axis or x-axis, and then there is one here, right? So basically there's two axes. What about the third axis? Like how can I, like where's the third axis? So the third axis is basically a button. So this button is the third axis. There is one axis in the x direction, one in the y direction, and one in the z direction. So as I explained to you before, right, analog and digital. In this, since the joystick can be in any place, right, in any direction in that square, so it can have some discrete values. It can be like point something something something, right? Like it can be between the values. Let's assume the maximum value is 1000 and the minimum value is 0. So it can't be either 0 or 1000. It can be anything in the middle, right? So that's why this one is an analog sensor. This is an analog sensor. So if you can see the pins, right, there's 5 pins. So out of them, 2 will be for the power and ground, obviously. VRX will be for the X direction, the movement in the X direction, and VRY will be the analog in the Y direction. So whatever the value of X and Y I'm getting, I will be displaying it to the Arduino. So this is basically like two analog sensors. The third one can be used as a digital input as well, because it's just a switch, either high or low, and depending on the press I can have some command. I can do anything I want with the switch. So this is digital and these two are analog. So for these, right, VRX and VRY are analog, but SW is digital. So if I were to connect this to the Arduino, I would connect VRX, VRY to the analog inputs A0, A1 till A5, but I would connect the switch to the digital inputs. All right. So that is something that you must understand. Next, we have an accelerometer. This has 5 pins. As I said, it is used to measure the linear acceleration. It will tell you how fast something is moving. It is also a very cool sensor, really important. Next, we have actuators. So what actuators basically do is they convert electrical signals into some sort of a physical like representation of that signal. So for example, a motor, if I can uh, supply some electricity to a motor, right, what would happen is the motor would rotate. So that is what an actuator does. I can also control these sort of actuators using my controller, using my microcontroller like an Arduino. But sometimes it might need some other additional components like resistances, capacitances, some other inductors, which I will not go to, like I will not teach in depth right now. But just make sure that you might be able to, like you might need some other components to make some components work. Like not all of them are plug and play. Like there's some sensors which will need a capacitor and which will need an inductor for it to work. So yeah, be like keep in mind that not all sensors are made the same way. Now, another important information to have is data sheets. What are data sheets? Basically, data sheets are PDF files of which will basically give you the specification of all the sensors. If I'm using an ultrasonic sensor, what are the sensors? Like what are the specifications? What are the power requirements? What is the accuracy? What is the precision, etc., etc. If I have to know, if I want to find out of a specific sensor, I will have to look for its data sheet. Data sheets are the best source to understand the sensors. They explain in detail how a sensor works as well. Quite a lot of times depends on the manufacturer who's making the data sheet and the sensor itself. But yeah, data sheets are the best source to understand the sensors. Here I have a few examples of data sheets. This one and this one, these both are basically for the accelerometer. This one will tell you everything you need to know about the accelerometer, like its operating voltage range, interface, sensitivity. See, the interface is analog quantity. See, it has to be connected to the analog input. The supply current, how much it should have. Everything it will be given in the data sheet. And it will also give the pin out, like whatever the pins are being used for. All right, and it will also tell you the direction of the 3 degrees as well. So, and datasheet will give you all the necessary information you need about a sensor. So for example, joystick का है, this you'll get information about the joystick in the joystick datasheet. This is just one sheet. There's actually multiple sheets for joystick, and there's multiple sheets for the ultrasonic sensor as well. So there's a bunch of sheets, there's a bunch of information that you can gather from the data sheets. You don't have to go through the whole data sheet. You just need to understand what is important in which sensor. Like for example, in the accelerometer, the operating voltage, the supply current, interface. That is mostly important, right? Because how do we use it? We need to understand. Operating temperature, we basically know like we're going to use it in our normal life, so it should be fine. And everything else you just need to look at it, like you just need to be aware of what you need from the data sheet as well. Do you guys have any questions?
Can we program any microcontroller using embedded C? Like any?
No, again, it depends on the processor, so the controller. The Atmega ones you can use embed C, but for others you can use uh, other languages as well. I don't want to go too in depth into other microcontrollers as well, but understand there's a bunch of microcontrollers available. There's a bunch of things that you can do with each microcontroller, and each microcontroller has its own advantages, its own disadvantages. And that's the same case with sensors as well. Each one has its own advantage, its own disadvantage. It is up to you as the designer or as the person who's using the sensor to make it in a way which is the best, which is beneficial to you as, yeah, which is the best for you. Basically, does that answer your question? Like there's other languages which you can use for other controllers, but mostly the industry uses embedded C. I have to say that, yeah. If you have no other questions, I think we can move on. I'm not going to be going too in depth into communication protocols, but basically what you need to know is that when as the sensors get more and more complicated, you can't just use simple pins to connect those two and then expect data to transfer, right? So you need to understand that a lot of these modules that of advanced sensors that you can get have some sort of communication protocols. That meaning they can communicate between each other using only that specific protocol. There's a bunch of protocols which are being used. Example, I squared C, this is I2C, UART, CAN is also used, SPI also used. There's bunch of advantages and disadvantages to each protocol. For example, I2C is 2-wire, it is a 2-wire system. SPI is a 4-wire system. CAN is also a 4-wire system. UART is also 2-wire. So there's advantages, disadvantages to each protocol. Like I squared C has noise issues. CAN is really good for cars, for in the automobile industry. And yeah, this is something that you must need to choose. Once you get into a high level of designing and programming, then you will have to pick one communication protocol so that it becomes easier for you to communicate with the sensors. Next, we need to know that not every sensor uses the same protocol. It depends sensor to sensor, like module to module, and maybe just make sure that whatever components that you're getting can interact with each other, can communicate with each other. That's something that you must be sure of, that you must understand. And it's up to you as the designer to choose a communication protocol. Next, we have a network of sensors. This is somewhat similar to like Internet of Things. Basically, what happens is in your own home or in your basically like anywhere actually, it could be in any network, in your office network or something, there'll be a bunch of actuators and sensors which are connected to the internet so that you can access that sensor, you can get information from it, or you can make something happen, you can actuate something using your phone or something. Suppose I'm in this room and I want to open my door, right? So what I would do is I would have a sensor at the door and an actuator as well. So whenever I press the actuator, then the actuator will actuate and it will open the door. But I'm still going to be sitting here. And how is this possible? Using wireless technologies. So using wireless technologies, we can create huge network of sensors, not just one or two, but a whole bunch of sensors. You can automate your whole house. You can connect every sensor to your of your whole house to the internet. You can connect toasters. You can connect waffle machines. You can connect the fridges to the internet, and it's really innovative. It's really cool nowadays. This is recent development in the field, something new. It's not a lot of people are still looking into it nowadays, but on YouTube you can see a lot of really cool videos on the network of sensors. People are very innovative and people are doing a lot of really cool ideas at in their own homes. And this is a very important topic, but it's a bit advanced. You won't start it immediately. There's a lot of things you need to understand before going to network of sensors. Now, these are the recent developments in field, like multiple sensors and single module like MEMS. MEMS has basically accelerometer, gyroscope, magnetometer, all on a chip that is smaller than this. Like your phones, right? Your phones have chips in them, which are basically MEMS, and they have accelerometer, gyroscope, and magnetometer all on the same module. So that is something is very important right nowadays. We're all looking to make things lighter, faster, uh, smarter, right? So MEMS is important in that way. Sensor fusion is also a very important thing. Like I said, you can have a bunch of sensors and then you can collect information from all the sensors to get the most accurate, right? So that to get the most accurate value, the most real value. So that is done using sensor fusion. Sensor fusion basically uses a bunch of algorithms and stuff to basically take out all the noise and everything from the sensor input. Is some advanced topic, you don't really have to look at it. And then we have improvement in manufacturing techniques. By improving the manufacturing techniques used to manufacture sensors, we are able to make them smaller, we are able to make them faster, we are able to make them more efficient. And then we have flexible and wearable sensors for medical monitoring purposes. You must have seen a lot of people uh, nowadays there's been a lot of focus on wearable technology for such sort of health monitoring uh, purposes, right? So a lot of sensors are being developed for that market as well, so that people are satisfied there. Now, improvements in wireless communication have also been recently done, like Bluetooth 4.2 BLE. That is also a recent development field that has been done recently, and it's a very cool thing to have. It reduces the power, it's faster, and it's really cool. IoT, as I explained, it is Internet of Things where you interact with the sensors and your actuators around your house, and it's really cool. These are the basic recent developments in the field. Next, future developments in field are leading towards this sort of a way. The people want sensors which are low power. People want smaller sensors. People want more accurate sensors, right? So these are the general fields where these are the general directions the field wants to go in. So people are doing a lot of research in these three, and apart from these three, they're doing a lot of research in a lot of other fields as well. But the main focus is being done in these three. ASML is basically a technology used to manufacture like chips, like the chips that you see in Intel and AMD and like chip manufacturers, right? Or may not even just chip, like integrated circuit manufacturers as well. IC manufacturers, they have a lot of technology that they use to manufacture the chips. So sensors and actuators are being used in this industry to create a lot of ICs in a much better way as well, to make smaller and faster and better ICs using ASML. Okay, do you guys have any questions? If not, I can move on. So how do I select a sensor? I've thought of a project, I have a project in mind. How do I select a sensor? Well, these are the basic things that you must realize. Understand the technical specifications of the sensor. You can use that using like data sheets. You can read that using the data sheet. The cost, you must be aware of the cost. You must always read the data sheet. If not just for the technical specification, but you might find something different, right? Something out of the ordinary, something very weird. So that's why you should always look and read at data sheets. Just glance through them. If you don't understand something, you can just Google it. Next, we have accuracy. Accuracy basically means that the repetition of result will be the same. Like no matter how many times I do the test, I will get the same result. That is what accuracy means. And we must have accurate sensors, because if I get one result one time and another result the second time, that's not a good thing, right? So I want it to be as accurate as possible to get the same result every single time. Precision means how, basically to what decimal point the output I'm getting, how precise the value that I'm getting is, how precise the reading is. Precision, like again, it depends on what you're doing, what your application is. If it is something that requires high precision, it will be very expensive, just saying. Next, we have dimensions, weight, positioning, basically mechanical constraints. These are posed by you know, like the conditions of the place. Like it could be very humid, it could be very hot, there could be a lot of physical movement involved. So to pick a sensor, you must be aware of all these things, that this is what my system is going to go through. So I need to have a sensor which is capable of this at least. So you must think like that, and you must be application based and project based when you're thinking of sensors and stuff. So you should always read and compare about sensors that work on different principles but can be used in your project. Like a lot of the sensors which are based on different principles but can do the same thing, like measure flow. Like they can also, yeah, with the rate measuring, or even the gyroscopes. There are a bunch of gyroscopes which work on different principles, but the precision, the accuracy, the everything else will be different because they work on different technology, they work on different principles. So you should be aware of at least the basics of this sort of things. Now I want you guys to think of a simple project that even you guys can do, something related to Arduino, maybe not, or you can also Google it. Like just think of something that you can do, right? Some project that you can do. You don't have to buy an Arduino. There is a site called Tinkercad where you will be able to simulate the Arduino. It is not, it does not have all the sensors, but it has quite a lot of sensors. And if you don't have an Arduino right now, you might want to check it out. But I would always suggest you buy an Arduino, you buy a kit, you buy something so that you are able to do it yourself with your hands and you're able to understand what is happening. Just think of some simple project, maybe some object detection or something. Just think of, yeah, and Google it. If you can't think of something, if you think that something is too hard, just Google it. Google it, look what is being done, look how it works, think whether you are able, like you can do it or not as well. And then yeah, you should do it out, try it out, you should try it out. That's what I'm trying to say. Unless you try it, you won't ever know whether you're good at it. So all I'm suggesting is try it out. Some of the suggested projects, I personally would say Google it, but there's also a bunch of Arduino example projects that you can look at. I showed that in the previous slide, like a bunch of slides ago. You can check out those projects as well. You can also do this. Now, the field of electronics is absolutely gigantic. There's so many projects, there's so many concepts, there's so many interesting things you can do, and there are so many interesting people that you get to meet, that you get to interact with when you're doing electronics. And it is truly so satisfying once you finish a project and it works and you see it work. You just it's just I can't explain the feeling. So we here at IE Mechatronics Students Chapter Manipal are researching about really interesting projects which we are trying to push into reality. We hold seminars and workshops on electronics quite frequently. So if you're interested, please do follow our social media. Please follow us. If you have any questions, please do contact us. There's a lot of smart people, especially professors in IE Mechatronics and in Manipal. The community is very helpful and helps in establishing fundamentals for future greatness. You must develop some skills, some specializations to achieve greatness in your field. You cannot, you must strive hard, you must grind, you must work on it in order to achieve something. And once you have those skills, once you've achieved that, then you can do something extraordinary. All right, so thank you everyone. I hope you understood everything that was told to you today. If you have any questions, please feel free to contact me or anybody from IE Mechatronics. We will try to help you.